Hey everyone, Miss Shane here. This is lesson 3. Technically, it is lesson 6.2.1, part 3, but that's kind of a mouthful. So from here on out, we're just going to start numbering our lessons. So last week we had 2, so those were lessons 1 and 2, which makes this one lesson 3. We're going to be focusing on solving equations rather than writing them. Your materials this week. I did post some guided notes on Google Classroom. These are meant to be in place of our notebook notes that we would take in class. So they're meant to be printed because you do have to sketch some algebra tiles on there. So if you can't print them, that's fine. Just use a piece of paper. And then you'll need a pen or a pencil. I do recommend taking notes on paper and not electronically for this one with the algebra tiles. You're going to need your textbook, either the online version or the hard copy. Algebra tiles are optional, and the equation mat is optional. We will get to that in a second, but I'm going to be using both of these in the video today. Our content objective is to be able to evaluate possible solutions to multi-step equations. And our language objective today is to be able to describe the steps used to solve multi-step equations. If you're using the physical textbook, let's turn to page 339. And if you're using the online textbook, we are still in section 6.2.1. We're going to be working with problem 6-50, solving for x. So 6-50, solving for x, talks about the lesson 6.2.1 resource page. And that's that equation mat I was talking about. It's posted on Google Classroom now. It's something we used in class to with algebra tiles to put different sides of the equal sign on, represent them on both sides of the equation mat. It also talks about algebra tiles here, which we can find also on Google Classroom under algebra tiles online and cutout. So this is what an equation mat looks like right here. Obviously, this one has algebra tiles on it already, but the one posted on Google Classroom is just a blank version. All right, so 6-50 part A says to build the equation represented by the equation mat at right, or use the 650 student e-tool. So this 650 student e-tool, that's that online version of the algebra tiles. So if you're using the online version of your textbook, you can just click that link and it will open up the online version. But if you're not there, then you will have to open up this post on Google Classroom and follow my link to get to the online tiles. All right, so build the equation represented by the equation mat, and that is done here. So these rectangles here are our x tiles. They represent my variables. These squares are my unit tile, right? They represent my number, the constants. Remember, if it's blue, it is positive, and if it's red, it is negative. Okay, so on the left side, I have 3x tiles, or 3x, plus 2 positive unit tiles, plus 2, and 1 negative unit tile. So altogether, I have 3x plus 2 plus negative 1. On the right side, I have 1 x tile plus 6 positive unit squares plus 1 negative unit square. So altogether, I have 3x plus 2 plus negative 1 is equal to x plus 6 plus negative 1. So that is actually part B on your paper. Record the original equation represented on your equation mat. So that's asking for that equation that we just said. So 3x plus 2 plus negative 1 is equal to x plus 6 plus negative 1. All right, so let's move on to C. We're going to simplify the tiles on the mat as much as possible. So our first step is to combine like terms. On the left side, I can combine my positive unit square and my negative unit square because 1 plus negative 1 is 0, so these cancel each other out. I can do the same thing on the right side with my 1 negative unit square and 1 positive unit square, and then these can just go away. On the left side, my 2 positive unit squares and 1 negative unit square has become 1 unit square. And on the right side, my 6 positive unit squares and 1 negative unit square has become 5 unit squares. So the second part of C says that we record what is on the mat after each legal move as you simplify each expression. A legal move is just any step while we're solving an equation that's mathematically allowed. So for instance, we couldn't combine these x's and these unit tiles because they talk about two different things. That is not mathematically allowed. But combining the positive unit tile and the negative tile or the negative unit tile is mathematically allowed, so that was a legal move. So we're going to record each step after we're done with each legal move. So we just combined our unit squares and we ended up with 3x plus 1 is equal to x plus 5. So we'll go back to our algebra tiles. Remember, 3x plus 1 is equal to x plus 5. I can't simplify anything else on each side by combining like terms. So now I have to start using 0 pairs to try and cancel out. Remember, I'm trying to isolate the variable and the constants. Let's break that down a little bit to make sure we understand what it means. So to isolate means to separate from others. So we want to separate the variables from the constants. In other words, we want to get all of the x's on one side and all of the numbers on the other. So we're going to use 0 pairs to do that. And I could add 3 negative x's on the left side, canceling out those, but then I would have to add 3 negative x's on the right side, which would make me, it would end up having 2 negative x on this side, and that's something I definitely don't want. Negative x's are not good. So instead, I'm going to add a negative x to both sides, canceling out the x on the right. So once those go away, the 3x on the left side turns into 2x, and the x over on the right side is now just gone, and I have 5 unit tiles left. All right, so we have to record our step after isolating the variable. So we brought the variable over from the right side, or I'm sorry, we got rid of the variable on the right side, getting rid of one on the left side at the same time. But now we have all of the variables on one side of the equal sign. Okay, so our next step is to focus on these constants. We need to get the all of the constants onto one side. Since the variables are over here, we want them all to be over here. So I'm going to add 0 pairs again, just 1 negative unit square. They'll cancel each other out, and then they can be removed from the equation mat. On the left side, that plus 1 just went away. And on the right side, that 5 unit tile just turned into 4. All right, so after isolating the constants over onto the left side of the, the right side of the equal sign, I'm left with 2x is equal to 4. All right, so remember, I don't want 2x is equal to something. I want x is equal to something. So I need to get these two x's apart. So I could add a negative x, but then I would have to add a negative x over here, which would make me have a negative x on this side and a positive x on this side. So variables on both sides. Instead, we're going to divide these two x's into 2 groups and do the same thing on the other side. Since this is a balanced equation, that means that x plus x is equal to 2 plus 2. Therefore, each x must be equal to 2 unit squares. So we write down our solution of x is equal to 2. Notice how I kept my equal sign lined up as I did each step of the equation. That helps me keep track of my 2 different sides of the equation. All right, so x equals 2 is our solution, but now we need to check it to make sure that it's correct. To check my solution, I'm just going to substitute this 2 for anywhere that I see an x. So I turned this x into a 2, I turned this x into a 2. And I see multiplication, subtraction, and addition. I'm going to do my order of operations, so multiplication will come first. Now I can do my addition and subtraction from left to right on both sides of the equal sign. On the left, 6 plus 2 is 8, plus negative 1 gives me 7. And on the right, I have 2 plus 6 is 8, plus negative 1 also gives me 7. Are these equal? Yes, therefore x equals 2 is the correct solution. So our question that we were trying to answer was, what value of x will make the expressions equal? So when we just found our x equals 2, we're saying that when x equals 2, both sides of the equation, both expressions are equal. When we checked our solution, we plugged 2 in, which means that 2 is that magic number that makes both sides equal. Like when we were comparing the two price plans with the bowling alley, 2 is that magic number that would make the cost of the two price plans the same. All right, so when you see what value of x will make the expressions equal, this is what we're looking for, that magic number, that when you plug it in, you end up getting something like 7 equals 7. All right, so let's summarize. That is our starting equation, 3x plus 2 plus -1 is equal to x plus 6 plus -1. First, we simplified both sides of the equation by combining like terms. Then we isolated the variable by getting all of the variables on one side. Then we isolated the constants by getting all of those single numbers, right, those unit tiles over onto one side. And then we applied our inverse operations. So up here, the 2 is being multiplied by x. So we have to apply inverse operations to undo it. Remember, inverse operations are opposite operations. Our operations are addition, subtraction, multiplication, and division. So the inverse operation of multiplication is division. When I divide this by 2, these 2's cancel each other out, and I'm just left with an x. But then whatever I do on the left side, I have to do on the right. So this 4 is divided by 2, and I get the solution of x equals 2. And then finally, make sure to check your solution. All right, so these are the 5 steps that we came up with to solve a multi-step equation. We also talked about a lot of variables, or I'm sorry, a lot of vocabulary in this lesson. So make sure that you're paying attention to each of these words. If there's something that you don't know, now is a good time to ask questions or to go back and watch the video. I will be posting an assignment to go along with this tomorrow morning, meaning Tuesday morning. So look out for that. Have a good day.